Okay, so we go now to creating ladder diagram from process control descriptions. So before we go into creating ladder diagram, we have to know first some basic rules in PLC programming. The first rule is a coil must be inserted at the end of the rung or network. Okay, so this one here is the coil and it should be inserted at the end of the rung. So this one here is what we call the rung, okay, or network. So an output which is represented by a coil should be inserted at the end of the rung or the network. The next rule is all contacts must run horizontally, and no vertical oriented contacts are allowed. Okay, so what does this mean? So example, all contacts must run horizontally. For example, this one, input 001 runs horizontally, then input 002 and input 003 and input 004 are in horizontal manner. Okay, and if you will add contact in between this line here, then that is prohibited. Okay, so it should not be done. Then the third rule is only one output may be connected to a group of contacts. Okay, so example again, this one here is represented by, or is an output represented by CR001, and for every network there should only be one output. So in every network, if you have, for example, two outputs, then it has to be connected to another network. Okay, so this part here of your ladder diagram is the input part, and this part here is the output part of your ladder diagram. So this input 001 here represents a particular switch. For example, switch 1, input 002 represents switch 2, input 003, and input 004 represents switch 3 and switch 4. Okay. Then we have here an example. Let's say example number 1 says the figure below is a start-stop seal circuit. When the start button is depressed, okay, the coil energizes. When the button is released, the coil remains on. Okay, it is held on by a sealing contact that is in parallel with the start button. The seal contact closes when the output coil goes on. Okay, so this is our elementary diagram that represents figure the problem in example number 1. So it stays here in the problem, it stays here, the start-stop seal circuit, this one here, is what we call the seal circuit. Okay. When the start button is depressed, this one here, the start button is depressed, then the coil energizes. That means that this motor here, the coil, represented by M, will energize. No? So once you push this one, the start button, then the motor here or the coil will energize. When the button is released, meaning to say that if the start button is released, this one here is released, then the coil remains on, meaning to say that the motor remains on. Why? Because of the seal. Now, again, when you push the start button, your motor here or the coil here will be energized. This one will energize. And at the same time, this M auxiliary here, okay, will close. No? Close na siya diha. Why? Because this M auxiliary here is actually the internal contact of your coil M. Okay? So if this is closed, even if you release the start button, the current will still be flowing from here, going here, and then going up here, going to the coil. Okay, so the coil will remain turned on. So this part here is what we call the seal. Okay, this one here is what we call the seal. So the coil here can only be turned off by pressing the stop button. When you press the stop button, automatically there will be no more current that will be flowing from this area here going towards your coil. Okay? Wala na siya ay mudagan nga current. So that the motor or the coil here will be de-energized. Once the coil is de-energized, automatically your M auxiliary here will automatically go back to its normal condition, which is normally open. Okay? That is how the problem is interpreted using the elementary diagram. Now, let's go to the PLC equivalent of this elementary diagram. Okay? So the stop here is represented by a normally closed contact in your PLC ladder programming. Then the start here is represented by a normally open contact because the start is normally open. Then the auxiliary here contact is represented by a normally open contact. And your M here, your coil, is represented by CR017. Okay? So the internal contact of CR017, which is your output, is this particular normally open contact, which is also represented by CR017. So when the start button is pushed here, then in input 002 will be closed. Okay, mag-close na siya. And then automatically, since input 001 here is closed, then automatically CR017 will be energized or will turn on. Now, if CR017 is turned on, automatically CR017 contact, which is the internal contact of CR017 output, will close. Okay, mag-close na siya diha. And then, even if you release the start button here, that means that or the input 002, when you release input 002, which is the start button, this will go, the input 002 will go back to its normally open contact position. Even if that is the case for input 002, your CR017 here will still be energizing because the current will now be flowing from input 001, since it is closed, going to CR017, which is now closed, and then going towards your coil relay. So this one here, as I've said, CR017 contact is what we call the internal contact of your output CR17. Now, what we have here on the right side is the Siemens equivalent of this particular problem. No? So, how do we represent this in Siemens way. So in this case, you have in your PLC logic, input 001 is normally closed. So again, in the Siemens equivalent, it will have to be represented by normally closed again, which is in this case represented, the syntax is I 0.1. So all input contacts are represented by input I. Okay? While output, say for example, this CR017 is now represented by Q 0. Q, no, in the output part. Now, the input here, input 002 in your PLC logic, this one here, is now represented by a normally open contact, which is in Siemens represented by I 0.2. And then the output, CR017, is represented by Q 0.0. Okay, this one here. And this output Q 0.0 has an internal contact which is normally open, which is also represented by Q 0.0. So that when input 0 I 0.2 is turned on, or the start button, this will close and automatically the current will flow from the input I 0.1 going to Q 0.0. And when the output Q 0.0 is energized, automatically this particular output here, the Q 0. Contact, internal contact Q 0.0 will also be energized. So that again, the same way sa atong discussion sa elementary diagram, if input I 0.2 is open, the start button is released, then still the coil here will be still energized. Q 0.0 will still be energized because of the seal here, which is Q 0.1, 0.0 I mean. Now, this relay here can only be de-energized if your stop button is pressed. Once the stop button is pressed, automatically your Q 0.0 here will be de-energized and making your output Q 0.0 here, which is the internal contact, to go back to its normal condition.